All right, let's get going. We're going to record this one for the virtual students and people that are absent. All right, 5-2, ASA Triangle Congruence. That's what we're going to talk about. Well, before we get into the nuts and bolts of this section, I want you in your book to have page 233 open. We're going to come back to that. Okay, so before we do that, from Friday we talked about in 5-1 how to prove triangles congruent. What must we know? Let me say that question again. What must we know in order to say, yeah, this triangle is congruent to that triangle? What must we know? Let me give you a picture. Go ahead and write this down in your notes. I mean, that's not too bad. Do those two triangles look congruent to you? Yeah, that's close, doesn't it? All right, so what must we know? If I'm going to say definitively, with certainty, with confidence, that these two triangles are congruent, what must I know in order to say it? Say it again? Okay, I agree. That's part of it. Yes. He said, those of you that couldn't hear him, that the angles are congruent. Evan? And the side lengths. I would agree. If I would say, watch this. Jimmy, don't be eliminating any of these letters and creating a bad word. On it, you, Jimmy. I did not. You were thinking it. I know how that works. That's true. That's true. Jimmy is very right. Okay, so 6 parts of one triangle congruent to 6 parts of another triangle. Everyone see that? This isn't anything new, right? So let's make some markings on our 2 triangles. Let's say that this angle is equal to that angle. This angle is equal to this angle. This angle is equal to that angle. Now, is that enough, though? Jimmy, if I just said 3 angles of one triangle equal 3, is that enough? No, it's not. Let me give you a quick illustration why. Those of you that watched the video from Friday, you already have seen this. Those of you that did not do that, you have not seen this. Evan, what's the measure of all those 6 angles? No, all 6 angles. You don't have to add them up. Just what's the measure of each angle? Each angle is 60 degrees. Is that possible that we could have a smaller triangle where all 3 angles equal 60? And we could have a larger triangle where all 3 angles... Is this a possible... Yeah. Are these 2 triangles congruent? No! Lance, this one's a lot bigger than this one. Are they congruent? No. They're not congruent. Just because... Oh, Jimmy, we're not there yet, but yes, they are. Thank you. They are similar, but we haven't talked about that yet. We'll get there. But they're not congruent. Okay? So just because I have 3 angles of one triangle and 3 angles of another, is that enough to say, no, it's not. Okay? And so on Friday, Thursday's homework, on Friday, we had to show all 6 parts. 6 parts here and 6 parts there. In fact, we had to use the distance formula quite a bit. I did one of the problems for you on the homework, on the video. We had to use the distance formula to show that the sides were the same. And so let's go ahead and put those markings in. This side would be equal to this side. This side would be equal to this side. And then the third side. Now, if we had that up until today, that's how we would prove triangles congruent. And this isn't anything new. Many times we've used triangle congruent statements like this. And we've talked about that there are 6 parts. Amira, can you name all 6 parts? Of the statement. Can you name all 6 parts of the statement? Nice and loud. They got to hear you on virtual. You got the angles. Side AB.
Line AB is going to be side BE.
Good.
Side BC is going to be side EF. And side AC is going to be side EF.
Outstanding. Chase, could you do that?
Yeah.
Does it make sense? Mira? Look at that. Virtual students, look what you're missing out on. Ooh. Okay. Does that make sense? Six parts of one triangle. Okay, but now look. We don't need all 6 parts. All right, so I'm going to write this. This is kind of the big idea. Put an asterisk here. This is kind of the big idea for today. We do, write this down in your notes, please. We do not need all 6 parts. We only need 3. Now this is an important word. Correct parts to prove triangles congruent. We do not need all 6 parts anymore. That was just for 5-1. Now we're going to learn there are actually 5 ways to prove triangles congruent only using 3 parts or less. Pretty interesting, I think. More powerful. I don't need to spend all that time finding 6 parts congruent to 6 parts. Okay? Okay, so, all right, the correct parts. Now, this is important. Why did I underline that? Because, as Jimmy pointed out earlier, here are 3 parts congruent to 3 parts. But are those triangles congruent? No, 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 no. So it can't just be any random 3 parts. That makes sense? It's got to be the correct 3 parts. And now we're going to discuss the correct 3 parts. All right, I have you turn to page 233. You still there? Okay. At the top of page 233, you're going to see what is labeled the ASA. They say congruence theorem. Is that what they call it? Congruence theorem. Please put that in your notes. The ASA congruence theorem. This will be, yes. We're recording it right now, Jim. I'm using shorthand. You guys are welcome to. Two angles in the included side of one triangle are congruent to 2 angles in the included side. It's kind of a new phrase, the included side. What's that mean? Well, let me show you. Let's say I have 2 partial triangles. Let's say that this angle here is 70. This angle here is 60. This is 10. This is 70. This is 60, and this is 10. Do you see how the included side is the side that's in between the angles? It's between the angles. Or another way to say it is that the included side connects the angles. Included. It's between the angles. or it connects the angles. That's what the term included means. Between the angles or it connects the angles. Got it? All right, so now the reason why I do this partial triangle is because those are the only parts that I have, that I know. I know that an angle, another angle, and it's the side between them are congruent to an angle, another angle, and the side between them. So this is what I have. If that's what I have, then I know beyond a shadow of a doubt that these two triangles have to be congruent. William, does that make sense? So now do I need to show that all 6 parts are congruent anymore? Nope. As long as I do the proper 3, I can't just do any random 3, but as long as I do the proper 3 parts, then I can say that the 2 triangles are congruent. Does that make sense? So one way to look at it is like this. Right here is an angle, right, Lance? I'm going to put an A there. Right here is a side, so I'm going to put an S here. Right here is an angle, so I'm going to put an angle here. Angle, side, angle. Now, even though I'm using the letter A and A, does that mean that these are congruent? No, not necessarily. I'm just labeling it. Angle, side, angle. See how I've said that? So it connects. The way that the word or the theorem is named kind of tells you what you're looking at. 2 angles included side. Angle, side, angle. 2 angles included side. So everyone understand the theorem? Good. Let's go to the top of the next page, which is page 234, number 6. I don't need much room in order to do this. Look at that triangle, the one on the left. I don't know, maybe, it's kind of looks like that. The measure down here is what? 38. And the measure up there is 72. Does everyone see that? If I had 38 and 72 without a calculator, Evan, what is that? Very good. 38 and 72 is 110. Well, what's the total degree measure of all 3 angles, Wattenbarger? If I add all 3 angles together in a triangle, what do they equal? 180. So if I take 180 minus 110, then that means this angle has to be 70. You see how I can conclude that? Everyone okay with that? All right. Look at the other triangle, William. This one's 38, isn't it? And is this one 67? William, add those 2 together without a calculator. What do you get? 105. If I take that from 180, William, what do I get? Is there any way that these 2 triangles are congruent? No way. No way. They are not congruent. I just answered number 6. Do you see how I did that? Just looking at if I could show that 2 angles of one and the included side and 2 angles in the included side. No. All right, let's move on. Let's go to example B at the top of the next page. This is a proof. How are we doing on time, Evan? What time do we get out of here? We get out at 11:14 and it is 11:02. Yes, we get plenty of time. Yes! All right, so let's try and make a picture here. Oh, that is awful. That is so bad. Amira. Don't laugh at it, Jimmy. I'll look at your triangles.
I just started framing.
Let's try it again. Okay, that's better. Still not great, but it's better. It is better. Okay, so we got A, B, C, D, and then the point of intersection here is E. Okay, got it? All right, now we're going to do the proof. Chase, what's the first statement that's given in this proof? Angle A is congruent to angle C, and so we're going to write our reason as given. Now, here's another thing that I want to help you guys with. Anytime you have a given statement and you have a diagram, make a note on the diagram. I'm going to go back to the diagram and I'm going to put angle A is congruent to angle C. By the way, what kind of angles are those? Those would be called alternate interior angles. Don't forget that stuff. Okay? Okay, so A is congruent to C. Amira, what's the second thing that's given? E is the midpoint. Raven, what does midpoint mean? Ooh, okay, so that's given. So it's all right. Let's look at the picture, Raven. I'm going to point at the picture, and it says that E is the midpoint of AC. Raven, are you looking at it? E is the midpoint of AC.
I didn't get that. Could you try?
I'm not talking to you. Look at that. Yeah, quit it.
Not sure I understand.
Good. I don't want you to understand. I don't know if I did that. That was funny. All right, Raven, back to you. I wasn't talking to you, Raven. I was talking to my watch. You weren't offended, were you? If E is the midpoint of AC, I'm asking Raven, but everybody should be thinking. What two segments are E? Outstanding. All right, I'm going to make another picture, Jimmy, so you can see it a little bit better. Okay, here's AC, and here's E. All right, now, Jimmy, we said that E is the midpoint of AC, right? Over here? That was given? So then Raven then concluded correctly that AE must be equal to CE. You see that? Pretty simple. Okay, now, Chase, we only have one way to prove triangles congruent. What is it? We just wrote it down. What is it? Just say three letters, Chase. That's all you got to say. ASA. ASA. That's the only way that we have. So far, I've shown in my picture an angle and a side. What am I missing? Another angle. So far, I've shown this. That's not a bad spelling of a bad word. Jimmy, quit. You keep thinking bad words. No, we need, what are we missing? We're missing an A. You gotta find, all right, so let's look at this picture. I'm going to tell you that it's this angle right here in the middle. But now we got to figure out why. Evan, why can I, what kind of angles are these angles that I'm coloring in? What kind of angles are those? Do you know? Not name them. What kind are they? It's a tough question. We haven't talked about them for a little bit. Jimmy? They are. No, that's a description of them, but that's not. Okay, so let me clarify that question, because that's a good answer, Jimmy. It's not what kind are they that would tell us that they're congruent. Obtuse doesn't say anything about them being congruent. No. Yes. Anybody remember? Okay, so let me show you this picture. Maybe you remember this. Angle 1 and angle 2 are congruent. What kind of angles are those? No, but close. Angle 3 and angle 4 are congruent. 1 and 3 are adjacent. What, Martyr? What kind of? Vertical, Raven. She got it right. Vertical. 1 and 2. Remember, when they're across from each other, they are called vertical angles. And are vertical angles congruent? Always. So let's go to step 3. We've basically done the proof. We just got to fill in the parts. So step 3 is going back to, I think, who told us about the point? Was that you, Raven, as well? That AE is congruent to CE. And that is the definition of midpoint. You know, you're going to find this a lot as we work on proofs. A lot of times what we say here helps us for the reason there. Look at the arrow. What we say here helps us for a reason there. That happens a lot. Definition of midpoint. AE is congruent to CE. Yeah. Okay. Oh, no. You can say it either way. No difference. That's right, Jay. Okay, so AE is congruent to CE. And then what we just got done saying is that angle AEB is congruent to angle CED. And Raven said again, vertical angles are always congruent. Mirror. Not sometimes. They are always congruent. You just got to remember that. Now we have enough, Kayla, to say that triangle AEB is congruent to triangle CED. What's my reason, Kayla? We only have one reason to show triangles congruent. What have we talked about so far today? What theorem did you write down? Thank you. You don't have to write out the whole theorem. You can just write the 3 letters. Now, here's a good habit to get into. I don't require it. You don't get extra credit for it. And I don't count against you if you don't do it. But it will help you. So what we've done is we've shown that 2 angles are congruent and the included side. I can go back through my proof and show, okay, right here in the given, that was one angle. Angle A and angle C. And then the other angle was right here. Angle AEB, the vertical angles. So I had given angle and then I had the vertical angles congruent. And then the S was right here. Why was the S? Because of definition of midpoint. So do you see that in my statement, I've got angle, side, angle? Therefore, I now can say and use that as a reason. That makes sense? It just kind of works its way right through. All right, that's it for the day. No homework for tomorrow, but we'll catch up. By the time we get to Thanksgiving, watch this. We will have 5 ways to prove triangles congruent. Right now, right now we have 1. Okay. So we're going to add 4 more to the ways to prove triangles congruent. All right, that's it. Good job. It's glad to be back. Good to see you all. All that mushy stuff.